I'd like to thank Team Louisiana for hooking me up with some threads that are making me a little hungry. But before I get to eat, we have to solve some math problems here. First, we're going to find the units digit of the sum of the squares of the integers from 1 to 2015. That's a lot of squares. We certainly don't want to multiply all those out. We definitely don't want to add them all up. So what are we going to do? Well, instead of just staring, we're going to do something. We're going to explore. Let's look at the squares of the first, say the first 10 numbers. So here are the first 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to square each of these and look at the units digit. We care about the units digit of the square. All right, you square 1, you get 1. Square 2, you get 4. Square 3, you get 9. Square 4, you get 16. Units digit is 6. Square 5, you get 25. Units digit is 5. Square 6, you get 36. Units digit is 6. Then 49. Units digit is 9. 64. Units digit is 4. 81. Units digit is 1. 10. Oh, that one's easy. That one ends in 0. All right, so I look at my first 10 numbers. And I only care about the units digits. The first key there, we forget about the tens, forget about the hundreds, forget about the thousands, forget about all that. We only care about the units digit. Because when we add this up, the only thing that's going to affect the units digit of the sum are all these units digits of the squares. Well, we don't have to care about the 0. And we can pair up the 9 with the 1. Pair up the 6 with the 4. Pair up a 9 with a 1. It's going to give us another 0. Pair up a 6 with a 4. It gives us another 0. We don't care about zeros. And we're only left with this 5. So when we square the numbers from 1 to 10 and add them all up, the units digit is going to be 5. Now what happens when we go from 11 to 20? Well, again, we only care about the units digits, so we're going from 1 to 9, and we have the 0 at the end again. It's going to look just like this. The units digits are going to be the same. We're going to go through the same pattern, and when we add them all up, we're going to get a units digit of 5. Same thing when we go from 21 to 30. Same thing from 31 to 40. So every batch of 10 like this gives me a units digit of 5. So if this batch of 10 gives me a units digit of 5, when I add the next batch of 10, I'm going to add a 5 and 5, I'm going to get a 0. We like zeros because we can ignore them. So every batch of 20 gives me a 0. Well, to get all the way out to 2015, I go 100 batches of 20. That'll get me to go out the first 2,000. And I take all those 100 zeros, add them all up, I still get 0. I like that because we can ignore the zeros. So from 1 to 2,000, we add up all those squares. The units digit is 0. And then we're just left with the last 15 there. I'm going to go from 2001 out to 2015 and look at the units digit of those squares. I don't care about the 2,000 bit. I'm just looking at the squares from 1 to 15 now. Now I already know that when I go from 1 to 10, I'm going to end up with a units digit of 5 when I add up all those squares. So then my next batch of 5 is just going to give me this group right up here. I know the 1's going to pair with the 9, give me a 0. 4 is going to pair with the 6, give me another 0. And I'm going to be left with a units digit of 5 when I go from that 2011 up to 2015. Look at all those squares, add them up, I'm going to get another 5. So my 2001 through 2010, that's going to give me a 5. My 2011 through 2015, that's going to give me another 5. Add my 5, I'm going to add another 5, and that's going to end in 0. So the key ideas here, of course, are, well, don't just stare, play around, look for patterns, look for something interesting, and focus on the units digit. We're on to the next problem, and I'm a little bit closer to eating some pie. All right, here we go. The units and the tens digits of one 2-digit integer are the tens and the units digit of another 2-digit integer. And the product of the two integers is 4930. Oh boy. All right, so we got all these words. We know what to do with words. We're going to write an equation. We're going to say our first integer is 10t plus u, where t is the tens digit and u is the units digit. And then, well, we're going to reverse that to get our other number. It's going to give us 10u plus t. And then we're told that when we multiply these two, we get 4930. And I don't know about you, but I'm not ready to multiply this. This doesn't look like this is going to help me a whole lot. So I'm going to forget about this for a minute. All right, don't jump on the algebra train too soon. Let's think about the problem a little bit. We're going to think about the problem. We're going to focus on the units digit, just like we did in the previous problem. We're multiplying two things here, and we're going to get, well, these are two integers, and we're going to get this integer over here. We're multiplying two 2-digit integers, We're getting a number that ends in 0. Not only that, these two-digit integers, we start with 2 digits, and then we reverse them. So ends in 0, that means one of our numbers either ends in 0 or ends in 5, and it can't end in 0, because then when we reverse it, we get a 1-digit integer. So we know that these 2-digit integers, well, one ends in 5, and then we reverse that number, and it starts in 5. So focusing on the units digit tells us right away, one of these digits is 5. That's really convenient. So now these are the two numbers that we're multiplying to get 4930. So we have a number here that's a little bit over 50. We multiply it by a 2-digit number, we get something close to 5,000. This little estimation as you go can save you a lot of work. I see something a little bit bigger than 50, multiplied by something else, and I get something around 5,000. This number up here has got to be close to 100. So this is a large 2-digit number. And then again, I look at this units digit. This units digit is a 0. Multiplying this 5 by something even. So I need something even that's going to give me a 2-digit number that's close to 100. I'm going to guess that this is an 8. All right, what we're doing is just, some logical guessing, little estimation. Let's see if we're right. We're going to go ahead and multiply these two out. It gives me 40, 64 plus 4 is 68, multiplied by 5, 42. Add this up, sure enough, we get 4930. Is that a little bit of logic, little estimation? We found our two numbers. We have to be careful, though. We have to go back. Read the question. We want the sum of these two numbers. Add these two up, you get 143. Now I've got one more problem to go before I get to eat some pie. All right, here we go. P is the greatest prime whose digits are distinct, that means different, prime numbers. We want the units digit of P squared. Well, let's see, the digits are distinct prime numbers, so that means the digits have to be 2, 3, 5, and 7. So I have to look at all the numbers I can make out of these 4 digits. That's a lot of different numbers. I want the largest one that's prime. Oh, well, I certainly don't want to list out all 24 possibilities and try to figure out which one's prime. But, well, if it's got to be prime, I know it can't end in 2 or 5. So it at least cuts down my search a little bit. I know that whatever my number is, it's a 4-digit number, it ends in either 3 or it ends in 7. It ends in one of these two numbers. So now I at least cut my search in half because I don't have to worry about anything that ends in 2 or 5. So now that's only 12 numbers to test. And we could do that. Or we could be strategically lazy and keep our eye on the ball. We only care about the units digit of P squared. And I really want to go get some pie, so I want to find a faster way to do this. I care about the units digit of what I get when I square this. Well, I already know from way back here, if I square something that ends in 3, I get something that ends in 9. If I square something that ends in 7, I also get something that ends in 9. So you know what? I don't care what the prime is. I know it ends in 3 or it ends in 9. Either way, when I square it, it ends in 9. And it is time for me to go eat some pie.